to another video, and in this video we will be looking at we want to understand model, relationship, cardinality, ERD, and all of that. Okay, very important concepts in data. If you've been following the SQL series, you see that at some point we emphasize on data normalization, to maintain integrity and all of that, reduce duplicate, and lots more. We did a lot of groundwork there, and of course in the foundation to SQL as well, we'll cover theories, the theory part, things you should know before you jump into SQL. Okay, so in this one we'll be going to our model view. Of course, we have our tables right here. We'll expand this, you see. Just collapse it. Now, the way it is now, we will see that we have three tables. They are disconnected. Nothing is connected to anything. They're just on their own. But earlier, when we imported the old messy file, we saw that it's connected to sales 2023, sales 2022, and all of that. But after we did our transformation, clean things up, the connection was not active anymore and it did not recognize it. So if in the first place we had used the file we used in SQL, that means the simple clean one that was not broken into chunks or changed, just for the process of cleaning and understanding how you connect to multiple data sources and different file formats, it would have just created the relationship automatically. So regardless of whether it created it or not, if you created it automatically, delete it. How do you delete it? If yours is created automatically, click on the line you see. Okay, so I'll just quickly do that behind the scene, then show you again. Alright, so here we have a relationship created. So if you already have yours, just click on the line and hit delete on your keyboard, and I'll just say yes. Okay, so it's gone. So if you have yours, click on it, that will delete it. How do we create a relationship? We have quite a couple of ways to do it. At the top, you see manage relationships. Okay. On the ribbon right here, if you click on it, you can also see, where's it again? Manage relationship. Okay. So these are some of the ways you can get into it. So let's go back to Zoom 100. Let's collapse this. All right. So this is what we have. And we want to create a relationship. Why are we creating a relationship? In SQL, how did we do that, or how would we have done that? Primary key and foreign keys. Because based on this data now, if we go back to the table view, we cannot really tell the name of the customer who made this sales. For example, this transaction, this first transaction. We can't tell. We have the customer ID, but we don't know the customer name, who is Emmy. So we want to be able to pull out the customer name eventually. Okay, if we want to be able to pull out the customer name eventually, then we need to connect these tables together. Okay, let's go back to this place. Now, we have different options of doing that. We can go back and use the merge option, which is just right on top of append in Power Query. And if you remember, let's take a look at it quickly. I mentioned, or I said about it, that it is the same thing you will do with joins, but I said we will not be doing that right here. I said we will not be doing that. Why? Because we will be creating a relationship instead. I hope you know that when we join, we lose data depending on what we currently have. It depends on the kind of join and depend on what we have. For example, left join returns all records from the left table and matching records from the right table. Same with right, I just switched the definition. For full join, records from both tables. For inner join, records come onto both tables, right? So we'll not be doing that in this case. So once we're able to establish a relationship whereby the data is not combined into a new table, they're still separate, but there is a link to be able to check anything on this table from here, anything from here to this table. Okay, so, and this will help us understand schemas. In Power BI, we have two major types of schemas. Okay, so I'll put that up in the browser. We'll take a look at it together so that you understand it. And they're just basically Star Schema and Snowflake Schema. Okay, so let's look at what it looks like visually. Let's jump into the browser quickly. So say schemas in Power BI. All right, so that's loading up. So let it load up. Let's listen to what the AI has to say later. Yeah, okay. So it says in Power BI, a schema refers to the logical structure of how your data tables are organized and related to each other in the data model. Choosing the right schema is critical for performance, maintainability, ease of analysis, etc. So majorly we have what? Star Schema, it says recommended, and we also have what? Snowflake Schema. So where's the second one? It's flat table, will not really concern ourselves that. It says Snowflake Schema. Yeah, pardon me. So Snowflake Schema. Now look at what the Star Schema looks like. And this will also let us understand facts and dimensions. Okay, what is facts? What is dimension? In visualization tool like Tableau, we call it measures and dimension. Okay, but here we call it facts and dimension. So what are facts? As it says, contains transactional or measurable data. Majorly, quote the word majorly, numerical data, where you have the actual numerical data. And if you have other kind of values, it will be that it's a connection or it's a foreign key to a particular record. For example, if you look at our cost or our sales data, let's jump back there. If you look at sales data, we'll see that apart from things that are related, like ship date, order dates, actually, the order ID, the order line, yes, customer ID is relating to another table, is a foreign key on this table, right? So majorly what we have is what? Numerical values, apart from this one that we created ourselves. Okay, so let's go back. So it says facts table contains numerical data most times, while dimension table contains the descriptive or attribute of those data. For example, if you look at it, contains descriptive attributes, customer, product, date, yeah, that can be extracted as well and all of that. So we'll see what it looks like in image form, but it basically means you have a table where others are connected to. So it says facts. So we have the date dimension. In our case, we don't have date extracted separately. So we just have facts in this case, which is the sales. So sales is connected to product and customer. So the idea of star is that, okay, there's a central table connected only to one other table. No, that's not the right word. There's a central table connected to other tables. So in form of a star form. Let's say we have one right here. So sales is connected to this, connected to this, connected to this, connected to this, connected to this. So that's just the idea. That's just the idea behind it. While Snowflake, which is similar to star, but dimension tables are normalized into multiple related tables. For example, go back to our data, customer. Much as customers seem nice, we can still extract locations of customers. Extract all the location parts separately. We can do that. We can. Okay, we can extract the location. Now, of course, with the customer ID. So the location is now connected to the customer table. Then the customer table is connected to the sales table. It will make more sense when you see a graphical representation of that. Okay, so this is what we have. So, okay, so customer ID, customer name, age. We have, of course, we've removed several columns. That's why it's looking small. So we can extract all of this three because they're about the location, and we keep this together, right? So that's something. Look at let's go back here. For sales, we can extract the date into another column completely. In advanced analysis, yeah, we'll probably do things like that, where you have the calendar table on its own, then you connect your dates columns to it, right? You can extract some other informations separately from this table and connect them. So it's saying similar to Star Schema, but dimension tables are normalized into multiple related tables. Why? Reduced redundancy can be useful when dimensions are very large, when they are very large. But in our case, we're good. More complex relationships, slightly slower performance in Power BI compared to Star Schema. Why? Because it's like a dependent. This goes here, then goes here, then goes here. You'll see it in pictorial form, and it will make more sense to you. We'll discard this. We'll discard this for now. So let's see what it looks like in image. Let's go to images. All right. So this is the idea behind this. For example, let's click this. Click that. How do I view? There should be a view button right there. All right, view image. So you can see there's a table in the middle. It doesn't mean we have to arrange it like this. It was only arranged like this to simulate the idea. Do you understand? So here we have manufacturer's table, manufacturer ID connected to this table using the manufacturer ID. We also have clients and client's name. So client ID is connected to this table. You can see that the date was extracted separately in this case. It's not really something that is compulsory to do. So let's look at a few more. Let's close this. Let's look at this. So it's just the idea of the star. It does not necessarily mean it has to be this way, but the point of a star is that it is not having other tables connected to a table it is connected to. All right, that doesn't sound good. But let's look at this view image. You can see this table. Now this, see, this is more of, this is not necessarily a star. This is more of a snowflake, where the central table is connected to this, but this is connected to this. For star, it is a direct connection from this to the middle table. Okay, it's not about the arrangement, so don't let that fool you. Let's look at this. All right, this is a very nice action. So you can see one table connected to the middle table, and the middle table is usually the fact. What is the fact again? Where you have more of the numerical values, but they can only make sense when you use them with respect to the qualitative ones, qualitative and quantitative basics of data, right? So that's what we have. So Star Schema. So let's escape this. Let's look at okay. We get here. Let's cancel this. Let's look for Snowflake. Building star schemas, star everywhere. So let's click on Snowflake. Alright, Snowflake schema in Power BI. Just look at it. Alright, so you can see the idea of Snowflake is that a table is connected to other tables. The table is connected to other table. Let's cancel it. Let's look for one. Snowflake. Let's click on this. Let's click on view. And you can see that this is connected to this, but country, region, and city is connected to this. So they were extracted out and now connected. So all of these things do not have direct connection to this. That's just all it means. That's all we're saying. So these three do not have direct connection to the one in the middle. So that's the idea of Snowflake. We break the table down into more chunks, smaller chunks, or smaller version. Let's look at this as well. You see, we have one in the middle. See, location was extracted. You can see what I'm saying. Location was extracted, and the state lookup code was extracted. So this is connected to this. This is connected to this. This does not have direct relationship with what is in the middle. The same thing. This depends on this. This is connected to this. So these do not have, all the tables do not have direct connection to the one in the middle. So that's the idea of snowflakes. And you can see that this guy right there is a snowflakes, not a star schema. I don't know this person, but it's cool. So this one is depending on this, and this is not directly connected to this. So this is the idea of snowflake schema. All right, let's just close it and jump back into Power BI. Okay, so here we are. Back to Power BI, and now that we understand that, we have Snowflake and we have Star Schema. Most times we'll just be using Star Schema. In our case, we can just drag the table and put this in the middle just to show something like that, but it's not really necessary. Let's see how to establish the relationships. All right, how do we do it? You can right click on this, manage relationships, right? Or let's take this back to 100. Okay, this is not bad. All right, so just go to manage relationships, and here we see a big table. Okay, so most times the button will barely show depending on your screen resolution and all of that, but it will be somewhere down here. Now look at this place, somewhere down here. Let me zoom in for you. You can see that it is there, so somewhere down there. And let me take out it. So it might not show properly, but you find your close or save button right there. So it says auto detect. Let's try auto detect. Most times if the column names are well compatible, it might just be able to detect relationship for us. So you can always try auto detect. So it says two new relationship which have been found, two new relationships which have been added to the semantic data model, and I'll click close. I think I closed it, so let's wait. Let's prefer it to do its thing, and boom, just like that, okay, just like that. So let it finish its work. We'll close it, and we'll see how to do it ourselves, okay, so that I can understand the intricacies. I don't know if that I don't know, but yeah, so I can understand the details, the workings, how it works, how to do it ourselves. So let's just wait for this to finish up working on it. So why are you taking forever to work on it? We could have done that on our own. Let's try to click close, come to the bottom and close it. Still working on it, but obviously you can see that it has now detected the relationship. You can see the lines, line here as well. Okay, let's wait for it while it's working on it. All right, it's done working on it, and yeah, this is cool, but we don't understand what just happened. We want to understand all of these things, how it happened and all. So we click on the line again, it deletes, yes, for sure. Work on it, just work on it, do your thing. Don't be fast, do not waste our time. All right, we click on this again and delete as well. Click it, delete, and yes, you want to delete it. All right, good. This is what we have. Now let's go back to manage relationship. You can see that auto detect can work, and it will be easy. Let me show you why it was able to work. We have custom ID here, exactly the same way it is typed there. It's the same way it is named there. The same way it's named there. The same way it's named there. So it will easily link them. Product ID as well. It will easily link them. That's what auto detect does. And that's why when we loaded the data in the first place with all those chunk tables in chunks, 2023, 2022, we was able to connect with them automatically. But let's see how to do it ourselves. We click on new relationship, and then this pops up. Save and cancel are just right there, just down below where my cursor is. Okay, so from each table, you can select a table first, and then now one easy thing is that click on the column you want to use, so that when you pick the second table, it automatically selects that same column. If you find it there, if it's the same name, it automatically goes to that column for you. And then we'll click on sales, and you can see it's highlighted automatically. But this is the most important thing to us. Before we look at this, let's look at the filter direction. It says single and both. So most times filter flows from the direction of one to the direction of many. Why? One customer can have many sales, so I can filter sales by one customer, by a particular customer, but it does not make sense for me to filter a customer by many sales. That's just the simple picture you should keep in mind. Okay, so most times we keep this on one. Can we want to do it both times? Sometimes yes, but majorly keep it on one. It's very good. If I click on both, it's saying applies your filter in both direction. Well, sometimes it asks you some funny questions and all of that. So that's that about cross filter direction. Very important to note. But cardinality. Now this is telling us how one table is related to another. And we can see we have a list of them. Many to one, one to one, one to many, many to many. So one to many and many to one is just the same. It's just depending on where the table is sitting. Okay, where the relationship is coming from. In this case, we pick this table first, customer table. So let's see. Without change, are you sure it's because we picked the table first? Well, let's see. Now we can find customer here again. So if we had picked sales first, then customer, that would have been many to one. So in this case, it's one to many. That means customer ID is not duplicated on this place, on this table, but it's duplicated on this table. Why? Very simple. On the customer table, customer records are not supposed to be duplicated. Yes. That's one. On the sales table, it is duplicated many. Why? Because a customer made several orders. Just the way you have a shopping platform where you shop from, then you go there, you buy this time, maybe in January you made 2 orders 2 different times. Then in February you go there, you made 5 different orders. In March, maybe just 1 single order. So you have multiple orders. So you have multiple records on your sales table. And that is one to many. It's as simple as that. One to many. Many to one is just the opposite, depending on the direction you're looking at it from. So that's that about that. We'll go online as well, see a few examples just to help us understand better. So next one is one to one. One to one in this case, let's say for a citizen of a country, you are meant to have one, for example, national ID card that identifies you as a citizen. One driving license. Just before you get another one, the one you have probably expired, right? Just one. Okay, the same thing. So one customer, one account number, right? Bank account number. You don't want 2 people to have the same account number, right? So one account number is tied to one customer. So think of those examples like that. Quite a number of them. So that is one to one. And of course, the last one, which is many to many, you can think of it as for a course in school, we have several students taking that course. And for a student will be taking many courses. So many courses, many students, many to many. Of course, there's usually a bridge between them, right? There's usually ground that connects them. Okay, so but that's the idea of many to many. That's the idea of many to many. So let's see if we can get something online with a few examples so that we can have a good understanding of the model, the relationship, cardinality, and all of that. So let's jump back online. Okay, so here we are. So let's look at cardinality. Let's say simplified with examples in Power BI. Let's just type something. You're gonna get results. Okay, so this is what we have, and you can see there's one to many or many to one. Like I said, it's just the same thing. Example says a customer table, unique customer ID linked to an orders table, multiple orders per customer. This one side is usually a lookup dimension table, and the many side is a fact table, just like we established a few minutes ago. One to one, both tables have unique values in the related columns, used when splitting large tables or storing supplementary attributes separately. And the last one is many to one, and you can see both sides have duplicate value, useful for complex scenario without unique keys, often requiring, you can see, a bridge table in the older models. So customer and products are linked indirectly via an order details table, right? Let's see, if we take this out, eventually this will connect to this will connect to this, but this cannot connect to this directly. So this is serving as a bridge between this and this. So we can see the customer name and the product name that a customer purchased. All right. So you see, best practices: always ensure one side has unique values. Always ensure the one side has unique values. So use that's one to many or many to one. Use many to many only when necessary, as it can complicate filtering. Things can easily get funny. Adjust cardinality manually if future data will change. If future data changes, will break. Let's skip all of this. All right. Let's see if you can see the image to just represent that. I think it's more of examples. Image will not do a good job. All right. So basically, that's just what it is. I've given you some examples on it. So let's close this completely and come back here. All right. Now that we understand this, so a single customer can have many orders. So one to many. And this is what we want. Yes, no doubt. This is what we want. So we just do a save. My button is down here. Look for yours as well. If your task bar is covering it, you can do it to hide the task bar. So click on save, and the line appears. Right? So let's close this completely. We'll not do the second one here. We'll see another way of doing it. And something to note before we go. Let's go back there and edit. Now, sometimes we connected this table to this table using customer ID, because if you click on the line, you'll be able to see it. However, sometimes you might want to, for example, connect date, a column here to another column here using different fields. Let's say we have a date column here and want to connect it to the date column here. But you will not want to have two relationships active. So the major one should be active, another should be inactive. And of course, you still do what you want to do, okay? And that is what we have right here. It says make relationship active. Now, if I go to many to one or many to many, now you see the error I'm getting. It says relationship has many to many. This should only be used if accepted column neither has. So it's not really advisable. You'll not even find this in Excel. It does not even, it's as it were, advice against it. Okay. So this says no, this is not a one-to-one. So if you're trying to make a mistake, it's also like, no, that's not correct. So keep it on many to one. So, and of course, it says make this relationship active. If I say make it inactive and I click save again, you see the third line. See, that means the relationship is inactive, and you can see it. That's just the activeness and inactiveness. If you have another one by default, it will be inactive. So let's click on this and make it active again. Click on it. Save. All right, good. We'll close it. Now we have this. How do we tell many to one or many to many from this place? Wait, there's something I'm saying here. Right click, properties. Aha. So it's supposed to be a single direction, not both. How did I know? The arrows were pointing upwards and downwards. So that means filter is flowing from here to here, but filter is supposed to be going from the side of one to the side of many. Like I explained, you can filter the sales table by a particular customer. So you see all the sales by that particular customer, because this is a many side. But it does not make sense to filter the customer table by different sales. It does not make sense. Does that mean we cannot have both direction filter? Yes, we can. But for this basic case, this is perfect, just single direction. And if you hover on it, you can see it will highlight the columns it's used to join. See, by hovering on it without even clicking, just hover on it. Just hover on it. All right. So I've been able to do this. And how do we detect many? If you look at it, this is one, and this is many. See the asterisk sign that shows or denotes many. All right. So this is one to many. How do we do this? Well, we don't have to go all the way again. We can just look for that particular column, left click, and once you left click, you slide your hand on your mouse trackpad and drag it. That means you just drag it over this place. Now, before you drop it, make sure it's showing that circle beneath. You see, showing this, that it is highlighting that same product ID. Now, why is this important sometimes, or if it doesn't detect relationships for you? It's possible that the way it is named here is different from the way it is named. But you know it that, okay, this and this are the same. So you can drag it manually yourself. So let's do that. So show this pop-up quickly. And you see it's pick the product ID for us, pick this for us. That's a shortcut, faster way to do it. And it's saying now it is what? Many to one. Unlike before that was many, one to many. Why? Because we dragged from here and dropped on this place. So it's picked the sales table first. Like I said, it's just the side. It's the first table that determines the side. So one to many and many to one are just the same. Make relationship active, yes. Click on save. And boom, just like that, we have a star schema. So it's just design of decoration. Maybe we want to drag this to the middle, customize on the left, and this is on the right. There's no need for that. So we already have our model perfectly developed. What is the issue if we don't have this connected? You won't be able to see things. You won't be able to do cross analysis. No, don't take that word too far. In context, I basically mean, for example, we'll not be able to see the name of a customer that made some particular purchases, or let's say total sales by region. Okay, but when we jump into visualization, we'll understand this better. Okay, so but for now, this is what we'll call it a day. Now we understand data models, cardinality, and relationship properly. Till then, see you in the next video.